All right, so now let's take a look at determining the probability of something occurring if we're dealing with binomials. We saw this again on lesson 10.5, this formula right here, where C represents a combination. And X is the number of times a certain event has occurred, by the way. So here it says a recent survey of high school seniors indicated that 78% of students plan to attend some type of college after high school. So that's the probability right there. 78% is your probability. Attend training or college after high school. 4 seniors, that's the number that we're looking at. 4 are randomly selected. That's going to be our N. And asked if they plan to receive formal training or attend college after high school. Construct a graph of the binomial distribution for the random variable x, representing the number of seniors who said yes. Find the probability that at least 3 of them said yes. So the function, if you didn't catch it earlier, let's first write out our values. N is 4. We want to have either 3 or 4 say yes. So x will equal 3 and it'll also equal 4. And I'm going to end up adding these together. I'll show you. That'll look like 7. Let's do 3 comma 4. And the probability of success is 0.78 or 78%, which means Q, the probability of failure, would be 1 minus that 0.78, which would be 0.22. And so to find our values, what we will type into the calculator is it's NCR. You have to use parentheses like this, where the N represents 4. And we're first going to type in a 3. And then the probability of success is 0.78 raised to the power of 3. It happens 3 times. We need 3 of them to choose to go to college. The probability of failure is 0.22 raised to the power of 1. Only 1 will not. And we're going to take that value and we're going to add it to the probability if all 4 said. We need at least 3, maybe 4 to go to college. So what's the probability of all 4 going to college? Well, it's the same probability, but this time to the 4th power. We need that probability to hit 4 times, and we need 0 people to fail. So we would add these up. Now, over here, if you go to probability distribution, you're going to see that I have some values here that's going to figure up if you put the table in over here. Just some data. But what I have, let me see, binomial distribution. Here we go. We have 4 trials. We have 3 successes. Probability of success is 0.78. Probability of failure, the calculator figures out, is 0.22. So the probability of having 3 people go is 0.4176%. So I'm going to kind of write this as we go, which this portion right here is approximately 0.4176. And then I'm going to do this again, but this time we're going to say, what if all 4 went? Well, the probability of that occurring is roughly 0.37. To use the same number of significant digits, let's say 0.02, like that. So if I add those 2 values together, I get the probability of at least 3 occurring is 0. Oops, I put a 0 in the wrong place here. There you go. Probability is 0.7878, or 79% chance that at least 3 seniors will go to college or get training. And that would be our solution there. So that's how you would interpret that data. Now, if we wanted to find the other probabilities of each of those, you would just type in, okay, what is the probability of 0? So the probability of 0 going to college is less than 1%. It's 0.2%. The probability that only 1 would go would be 3.3%. The probability of 2 going would be 17.7%. And that's how you could find the probability of each one along the way. So now I'll let you try DOL number 7. Pause the video if necessary.